All right, everybody, welcome back to our last video for Unit 9. Today we are taking a look at solving for surface area of triangular prisms and pyramids. So remember, we want to be using our nets to help make things a little bit simpler. If we do not have access to these on whatever platform that you are working on, it's good to practice this on your scratch sheet of paper. So going from a three-dimensional object down to a two and how it unfolds will definitely benefit you in the long run. So couple things to keep in mind. First, we obviously want to be drawing our net to identifying what type of prism are we dealing with. Is it a triangular prism where it looks like the two overlapping, kind of like this, where we have three rectangle sides and two triangular sides, or is it dealing more of a rectangular pyramid where we have our 4 points and that one on the backside, so we have a square base, or if we have a triangular base where we have our points here, so we have a triangular base down low. And then we also just need to keep in mind what we're solving for, area of a triangle, base times height divided by 2, or if we're solving for area of a parallelogram, particularly with either squares or rectangles, just base times height. So let's dive right in. We've got 3 practice problems that we'll work on. We'll start off with a rectangular pyramid. Sorry. So the first thing that we want to recognize is which one are we going to have, which net is going to fit, and we really need to pay attention to our measurements of our faces. So we know that this base is 12 and this base is 12, and this this slanted height is worth 7, and this slanted height is worth 7. And when we unfold the pyramid into our net, we call these lateral heights. So these are slanted in a 3D, and then when it's put in a 2D, it's just lateral height. So these ones have a base of 12, height of 7, all the way around. So this looks pretty good. This one, however, we have our 12 by 7s, but we have a 12 by 12. So if we refolded this back together, what we would have is having 2 short triangles on the side, but then over on the side that we see, it would be significantly higher than the other side, and they wouldn't even match. So there would actually be a gap in between the two, so it wouldn't fold over perfectly. So it cannot be this one. So now all we need to do is find the area of our base and then one of our triangles, and then we would just multiply by how many sides there are. So if we multiply 12 times 12, we get 144 square inches. And then if we have 12 times 7, and then we would just divide by 2. So if I go 12 times 7 divided by 2, what we can do, we can multiply and then go. But if we recognize that 12 is divisible by 2, we can cancel these guys. So that would just get us 6, and we would end up with 42. So our area of each of these triangles, since they're all the same, is going to be equal to 42. And we can do a couple things. One, we can add them all up. So we would just have 144 plus 42, 42, 42, and 42. And for some of you, you may need to do this so you just have your every single area accounted for. Or on the other side, I'll do it in green. We can go 144, and then if we just multiplied 42 times 4, that gets us 8 and 16. So we could add here, and then we go. You'll get the same result. It's just one way is a little bit quicker. So then on the green side, I would have 12 carry. That gets me 10 plus 1 gets me 11, and I end with 312. And on the other side, if I count 2, 4, 6, plus 4 is 10, plus 2, that gets me 12. And then 4 times 1, 2, 3, 4, 5, that gets me 20, plus 1, 21, 2 plus 1 gets me 3. So the surface area for this rectangular um, uh, what is it? Rectangular pyramid, sorry, is 312 square inches. So let's do a triangular pyramid now. So we need to recognize that we have a triangular base. And so now we just figure out which net we are working with, and then we can go from there. So what we need to recognize is our base is 8, has a height of 8.7 and a base of 10. So we want to look down there. Both of these bases are good, but on this side, we only see side 1 and side 2. They don't account for the back side. So here we cannot use because we would have a total of 4 sides. We have 1 down below, we have 2 here, we have 3 here, and then on the back side that we can't see, we would have 1 more. So by default, we have to use this triangle. So if we want to solve for base first, 8.7 times 10 is just going to get us 87. And since it's a triangle, we still have to divide by 2. So 87 divided by 2. 2 can go into 8 4 times. Subtract by 8, and we get 0. We have to drop our 7. 2 can go into 7 3 times, which gets us 6. And we subtract. And since we don't have any more, we have to put a decimal point and a 0. We drop it. 2 can go into 10 5 times. Subtract by 10, 0. So our area on our base is going to be equal to, and I'm going to write this large, 43.5. And then we just need to solve for the area of one triangle. So 10 times 17 gets us 170, and we have to divide by 2. 2 can go into 1 no times, so we have to go to 17, and it can go in 8 times, which gets us 16. We subtract, and we get 1. Can't go into 1, so we have to go into 10. 5 times 2 gets us 10, and 0. So each of these triangles are going to be equal to 85. And then we can do the same things over. We can go 85, 85, and 43.5. If we add that up, we have 0.5. And then we have 5, 10, 15, 16, 17, 18. We carry the 1. And then we have 8 times 3. That gets us 24. Plus 4, that's 28, 29. And we get 298.5 feet squared. And that is it for our triangular pyramids. The last one that I want to do is go over our triangular prisms. So what we need to remember is the face on the back side that we can't see and this triangle that we can't see on this back side. So when we have these nets with, what we also need to remember is since we have this triangle on the back side and we have this larger box down below, we have a total of 5 faces that we need to deal with. So if we just count up both of them, 1, 2, 3, 4, 5, this one just off the bat looks good. Let's check the other one. 1, 2, 3, 4, 5, 6. Can't be that one automatically. So if you're pressed for time on a test or quiz, that is a way that you can, sort information pretty quickly. So we know it's this one. So we are going to go ahead and solve for this. So if we multiply 25 times 13, we can do a couple things. If you think of like dollars, dollar can be cut up into 25 cents. Or if we multiplied, we would have 25 times 13. We would have 15. 2 times 3 is 6, plus 1 is 7. We cancel those guys out, drop a 0. 1 times 5 is 5. 1 times 2 is 2. We get 5. We get 12. Carry the 1. And we have 3. So we have 325 for the big box. Down below, if we have 25 times 12, we just take away 25. So we would just have 13. And then if we have 25 times 5, that would just get us 125, because 25 times 4 gets us 100, and then plus another 25, we get 25. And if we have 12 times 5, 12 times 5 divided by 2, if you already know, 12 times 5, that gets us 60, but we can still 60 over 2, which gets us 30. So this area is 30, and this area is also 30. So we can just add these all up. So I'm going to go 325, 300, 125, 30 and 30, or I can just go 60 to make it a little easier on me. So 5 plus 5 gets me 10. I carry 2, 4, 6. That gets me 10, plus 1 gets me 11. 3, 6, 8. So I end up with 310 feet squared for my answer. So that's a really important thing. When we're solving, we want to get these into our nets. It makes it a little bit easier for us to kind of see those sides that we typically don't see within a three-dimensional shape on a 2D screen. So thank you so much for watching, and if you have any comments, go ahead and put it in the section below, and I will see you in the next video. Take care.